Hi there. This informal video is to just help you get up and running with the EntailmentBank tree-based annotation tool. So to start off, we're going to work on a fresh Ubuntu 2004 long-term support virtual machine here that's running in VMware. And this is pretty much a fresh virtual machine. It has Chrome on it, it has the Git tools, but that's about it. And here I am on the EntailmentBank tree annotation tool repository that can be found on GitHub. And so the first thing that we're going to do is clone the repository here. And so I'm going to make a GitHub folder, git clone, and then we'll paste that in. It's going to take a second or two to come down. There we go. And so here is the EntailmentBank repository with the code that we use, as well as a couple of scripts that get the server running. Before we get the server running, we have to install a number of packages that enable this to happen. And so the first one is yarn here. And yarn sort of goes over top of node.js. And so first we'll add this, oops, this really is a fresh virtual machine. We'll install curl here. And I'll make our terminal a little bit larger. So it's much easier to install packages using apt, and so we'll just add the repositories here for being able to use apt. There we go. And so now sudo update, or sudo apt update, and then sudo apt install yarn. Oops. Sudo apt install yarn. And I should install yarn and node.js. Great. And so a way that we can verify that all of this worked and that we have a version that is likely to be compatible is we can type in yarn version, and we see that this is installed version 1.22.15, which is about compatible with this, and we'll also check on the node version 10.19, which is good. So now we need to install npm, the node package manager, and this is just sudo apt install node npm. And this one does take a second to install. There we go. Okay, and we can verify that this is an appropriate version of npm 6.14.4. And that's the one that's listed here in the repository, so this should be good. Next, we need to install a backend server that's used for serving the Json database. It's called Json server. This has sort of been updated a bunch of times since the development work on the EntailmentBank annotation tool happened. And so we need to specifically install version 0.16.1, since there are a bunch of breaking changes that have been made in terms of recent versions and whatnot. There's a script that should let us do that here called install JSON server. You need to run this as root. There we go. And again, we can verify that JSON server is running with the version that we expected. There we go. 0, 16, 1. Okay. So once we've done that, we should nominally be able to actually start running the EntailmentBank server, which happens in two parts. There's two parts of the backend. One is the JSON server itself, and then the other one is the node.js server. And these are with the two scripts here, the start JSON server and then the run tool scripts. First thing we need to do before we run the client is to run the JSON server. And so I'm just going to run the JSON server script. It'll say, hello, I'm loading up your data, and then it will load it up and serve these for us to use. Now, independent of this, we need to open up a second tab here. I'm just going to open up an entirely new terminal window. The KDE person. New window. There we go. And so now that we have the JSON server running back here, we need to get the actual tool running here. And this is something that might actually take a second or two to get running. So GitHub, EntailmentBank tool, and it's this one down here, the run tool. So let's run that, and it requires us to give it sudo. Or sorry, that's the JSON server. That requires sudo. React scripts not found. Let's use npm install. So install the various packages. Okay, and then run tool. It'll take a second to compile, typically. There we go. And then, ta-da, the tool starts. And then it takes a second to actually load the data from the JSON server. Now, you can see that the interface here is a little bit squished for this video. This is meant to be run on a larger screen. But it's good enough sort of for our purposes here. So just to orient you to exactly what the interface is, since there's lots of buttons and knobs and things like that to play with, probably the main part of the interface that matters over here is the question indexing. So what question are you on? You can sort of index it with these buttons here and skip larger numbers with the larger buttons here, and it should also work with the keyboard keys as well. So typically what the interface looks like is it has a list of questions. Typically it also has their answers, and then it has a semi-structured explanation, which is the explanation that you or nominally the person who's doing the annotation work here has authored for this particular question. By default here, most of these questions, so most of the questions here have been annotated, but a couple of them haven't been. And they may just have sort of half explanations or partial explanations or no explanation at all. And we'll just sort of grab one and play with it. Here's one that's empty that we can use. Now, the main sort of thing to know about this semi-structured annotation tool is that the explanations are divided into this sort of categorical structure. So there's high-level structural components like core concepts to answer this question are such and such. In this example, while not critical, answer the question, and so on and so forth. In an earlier version of this work, before using tree structured explanations, we just had the idea of using basically structured explanations that were fairly loosely structured except organized by these categories, before ultimately going to the more binary tree structure that we ended up using. These sections are sort of legacy and built over on that, and you can sort of see if we go to another explanation here. For example, this question here is, what motion causes day and night? The answer is the rotation of the Earth. And then this is the semi-structured explanation that a annotator has written down. The explanation that we're looking at here has two main parts to it. One part that, if you've read the EntailmentBank paper, you'll be familiar with is the tree. And that tree, the entailment tree, starts with the in summary section, which is sort of down here in the actual tree widget, and it's up here in the sort of plain text version of the explanation. So that's the tree part. The other part that we have variously called the explanatory worksheet, or just the sort of loosely structured explanation, is this bit at the top. And the sections are delimited by these sort of blue markers, and then the facts for the explanations are included typically in white if they come from the World Tree Corpus, or they'll be in this sort of orange highlightish color if they've been written in by one of the annotators because an existing fact didn't seem to fit their needs. So these blue sections, we haven't done much with this data. You're welcome to use it, but what it does in terms of the annotators is that it helps you build sort of like a worksheet for how you plan on building the structured explanation, particularly the tree structured explanation, particularly if the tree is pretty big. One of the questions is, where do you start? How do you go on in the process? How do you know when you're done, and so on and so forth. From doing explanations a lot and doing a lot of explanation annotation, what we've found out is that there tend to be a couple of really high-level major categories for the kinds of facts that you tend to include in explanations. One major category is the idea of the core concept. So if you have a question that's about changes of state of matter, this might be the question, or this might be facts like boiling means changing from a liquid to a gas by adding heat energy, big core concept facts like that. Conversely, the in this example section basically ground the core concepts in examples in the question. So if you're boiling water, you might have facts that are about water being a particular kind of liquid or something like that. In this particular example here, what motion causes day and night, we see that the core concepts are about planets rotating in planetary cycles, and that this particular question is grounded in the example of a particular planet, in this case Earth. So that sort of hopefully helps delimitate what the difference between core concepts and sort of grounding or example concepts are. Sometimes you'll also see a couple of other sections. We have background knowledge that's sometimes important that we like to enumerate when working with these. And we also have word synonymy relations. So in the original world tree explanations, the explanations were basically bound, or the different facts in the explanations were bound based on word overlap. So two facts having the exact same word in them. And so we needed a lot of this lexical glue to hold them together, whereas that's not really required for the tree structure explanations, but that's sort of still there. So those are our large blue sections. Let's get to the tree section here. So let's look at one of the example trees that's sort of been done already. Here, the tree basically says, in summary, let's recap just so that we can sort of keep ourselves on the same page. What motion causes day and night? The rotation of the Earth. Why does the rotation of the Earth cause day and night? In summary, and we can sort of read it directly off here, but I like to read it off as the tree. In summary, because a planet rotating causes cycles of day and night on that planet, and Earth is a kind of planet that rotates on its tilted axis, and rotation is the circular movement of an object around a center or an axis, we can infer that Earth rotating on its axis causes the cycle of day and night on Earth. This is how we read these relations. The sort of nodes, or parent nodes, are typically these summaries here, where it groups together all of the direct children of them. So because a planet rotating causes cycles, and Earth is a planet, so on and so forth, and rotation is a circle. Basically, these direct children here, it groups them all together and then allows the annotator to write a direct conclusion or a direct entailment from those facts. Nominally, nearly all of the entailments in EntailmentBank have two children coming to them. So we take two facts and we entail a third fact from those two. There are cases where that doesn't hold. So in some cases we have more than two, typically 3 or sometimes even 4 facts. They're very rare. There are typically cases where there's sort of what I tend to call multiple groundings. So if you have a fact that's something like melting means changing from a solid to a liquid by adding heat energy, and then you needed to ground a specific solid and a specific liquid, like liquid water is a kind of liquid and ice is a kind of solid, then typically that would ground that entire fact down so that you know that melting means changing ice from ice to a solid or liquid water. So most of the time there are 2 facts entailing a third, but some of the time you do get multiple facts, as we see here. When the annotator goes to build this tree, to make the task easier, more tractable, and so on for the annotator, what we've done is over here on the sidebar, we've picked out a short list of facts that are most likely to be relevant to building this particular explanation. These facts come from the gold world tree explanation corpus facts, but they also all of these facts are from world tree. The facts in this particular case have been pooled based on whatever facts the gold world tree annotators put in the particular explanations for these, as well as ranking of the entire corpus of facts using, I think in this case, a TensorFlow ranking BERT model that gives relevance scores based on how relevant that particular model thinks a given fact is. And so usually there's a short list of 20 or 30 of these, and the annotator can sort of pull these over into the tree. Now, I'm just gonna, I moved over here one extra question here. And so what I'd like to do here is I'd like to just sort of drag and drop and show the particular process of how this works without going into too much detail about this specific question here. So how this basically works is we can basically come and drag facts over into our explanation, and we can make them children or we can make them parents and so on and so forth. Now, at the sort of highest level of the tree, the only facts, or sorry, the only things that we should have are these major colored subsections, and so the blue sections are the sort of green section down here. And so I'm just again, the fact that, or the explanation that I'm going to make is nonsensical. I'm just doing this for the sake of argument, or the sake of demonstration, I should say. So if we come down here and say we had a couple of facts that we want to build in here, then away we go. And then maybe we want to, let's add in a little bit more structure here. We'll just sort of pool in a couple of facts. And then let us structure this as a tree. So I'm going to drop in the write-in marker, which allows us to write in essentially our own conclusions in this case. And so imagine that we had, again, this is going to be nonsensical. Imagine that we wanted to make an entailment relation where we had two facts entailing a third. And so fact number one is the Earth being tilted on its rotating axis causes seasons. And the second fact is December is during winter in the northern hemisphere. Here we could write in whatever we thought that would entail. And here I'm just going to put example entailment, just because it doesn't actually make any sense. Now, note here this doesn't actually structure it as a tree in our sort of plain text explanation here. What we do to make it structure as a tree is we click down this sort of discourse connective section here, and we select this one down here, which basically automatically infers the structure of the tree. And so here what it'll say is, because fact one and fact two, we can infer example conclusion. And so here I'm actually going to change this to say example conclusion one. And then maybe we'll add in another example conclusion down here. I'll just kind of grab another random fact down at the bottom, and I will drag another write-in conclusion and put it there. And we'll make these two the children facts, and then this one could be example conclusion 2. There we go. And then we'll add the auto discourse marker here, and then away we go. Because fact 1 and fact 2, we have example conclusion 2, or we can infer example conclusion 2. And then to make this a tree, because right now we have two branches of a tree, we could imagine having an overarching conclusion here. Example conclusion 3, and so on and so forth. You get the idea here. So because example conclusion 1 and example conclusion 2, we can infer example conclusion 3. So that's basically the gist of it, and that's what how the tool operates. The rest of the bits and knobs and bells and whistles on this are just to make your life easier in different ways. So the pencil mark on a given fact allows you to modify that fact if needed. The eyeball highlights that fact up here in the plain text version of the tree structured explanation. You can copy facts, you can remove facts, and so on and so forth. But the gist is that's how the process goes. And so if you wanted to make a tree that was even bigger, you can drag and drop even more facts on here. Just for the fun of it, why don't we do that? And so I will add even more facts on here. The nice part about this interface is that it allows you to really manipulate the structure of the explanation and the ordering of the facts very, very easily. Example conclusion 1a. There we go. With different versions of this tool, in the prototype stage, it was very hard to modify the structure of the explanation, but here it's clear that with this sort of tree view, you can make modifications to the larger structure of the explanation very cheaply, which seems like it's one of the main usability aspects of a tool like this that just has to be done. So I hope that sort of illustrates the main structure of the tool and whatnot. One of the main questions that you might have is, where do these facts come from? You could certainly modify the tool for these to be generated online from a model, but right now these all just come from a JSON file that's pre-generated. And so, for example, for all of these, I pre-generated, I ran the model ahead of time, and then just took the top rankings and populated them in the file. Now, that's authoring an explanation. Up here, there's lots of bells and whistles and other things, and I'd like to highlight some of the main ones. So over here, we have a bunch of buttons that are particular to what we call status flags for a given explanation. So what we found over doing this for a couple of years is that rarely do you do a great job of building a good explanation the very first time around. Usually what you need to do is write down an explanation and then have another person review it. Or you might find after doing this for a while that some explanations are pretty easy for you to do and you're pretty good at them, but some explanations you're just going to look at and say, I don't really know. I'm going to have to come back to this one. Others, you come back and say, I really don't think that this explanation could be done with this particular formalism. Maybe it's got lots of spatial knowledge in it or math or something like that. And so you need some way of basically keeping track of it and auditing all of your work in the explanations and whatnot. So we have a bunch of these buttons basically. And so this sort of thumbs up button means I've gone through it. I'm pretty sure that I've made a pretty good explanation and I'm ready for another annotator to come take a look at it and review it. This second button here basically says, I am that second data annotator and I've gone through, I've checked this explanation and it looks good. This button that we added in says you basically need minor edits to your explanation in order for it to be correct. This one here says, I'm not really sure how to approach this explanation. Maybe one of the other annotators can take a quick peek at it and give me their thoughts on how I think that it could be done. And this sort of terrible red caution flag basically says, I think this explanation is really, really hard, and I don't think that I could do it properly, or I don't think that it works well with this formalism. Again, maybe it's really spatial or maybe really mathematical or something like that. And so I don't think that we should do it, is how that's basically been flagged. Building a large corpus of explanations is sort of a very pragmatic activity, and you usually want a lot of good explanations. And to get a lot of them and do it at scale, you have to spend only a certain amount of time at a given explanation. And so if it turns out that you might have to spend 20 minutes figuring out one explanation, whereas normally you could do maybe 5 or 6 other explanations in that same time, usually we just mark it as a hard explanation and sort of move on with our lives. And then this last one is sort of just a fun flag that you can mark it as a tree if you want to. So these are the flags. This is a timestamp for the last time that this explanation was modified, just again to have some sort of tracking here and auditing. And in fact, you can put your initials in here so that it keeps track of whoever last touched the explanation basically, and whoever last did something. So here we can see that now that I've populated my initials and I've done anything on it, like changed the status of it, now it's stuck my initials on this explanation in its most recent activity. So those flags are for sort of auditing the data. These last buttons are for keeping track of, or rather more tools, I should say actually, that help you work with the data. So this button here allows you to copy an explanation. This button here allows it to sort of refresh the interface. Every now and again there's an artifact or two that pops up because this is an academic project. This save button does a hard save of this particular question. Normally questions are only saved to the database once you move on to the next question, but this one will do sort of a hard save. This one here gets a fresh copy of the entire database from the JSON server. This one here exports I believe a tab delimited text file that gives you statistics of the data set. And then probably the most important ones are right here. These allow you to export the entire database of explanations. And they do it in a method that's a little bit more user-friendly and structured than just grabbing the JSON database directly. So these ones are a little bit more user-friendly. And then last but not least, motivation is key when doing a large project like this, and it's usually nice to see your progress. And so here you have basically a histogram of the different proportions of flags that are being that are in your corpus. And so what you see when you start off on a project is that you have almost none of them actually done. But what you see sort of as you go is that most of them are sort of done. You get an idea of how many of them are sort of critical failures, how many of them need you to come and have another look at them, and so on and so forth. So those are just sort of rough statistics here. Okay, so that sort of covers the use of the tool and how you go about installing the tool. And if you have any questions, please either email me or post them to GitHub. Thanks.